Moby.
Hi, how are you?
Great, how are you?
I'm good. I'm just moving this a little bit so my squirrel is in the picture.
Oh, that's nice.
That's a good squirrel.
Mm-hmm.
Thanks.
Who's ready to do some math?
Me. I'm Natalie, by the way.
Hi,
Thanks
Nat.
Just keep it in.
Sometimes I forget about Natalie because
I'm here.
poor Natalie. Okay, so Natalie, me, and Moby, we're going to do a box plot.
I don't even know what two words you just said.
A box plot. Okay, so I'm going to share my screen.
Never heard of this before in my entire life.
Okay, we'll show you some. So firstly, we have some information from your most recent album. And this is the length of each song on the album, which we've done some work with before with standard deviation. We had found in the past that the mean was
7.2 or something.
6.61.
Sure, that.
So anyway, we've got the information on your album, and we want to know about what's called the 5-number summary. And this is all about positioning. So we're going to go ahead and put all of the data in a list on our calculator, or we can do this by hand, but it's a lot faster on your calculator to go ahead and just get the 5-number summary by going to 1-bar stat, and the 5-number summary will tell us our minimum, our maximum, and just kind of looking at these, what is our lowest, our shortest song length?
5.5.
5.28.
Oh, I actually, oddly enough, I thought you had them, because they do get generally longer as it goes on. I thought you had them arranged by length.
Oh, I don't. It looks like it's arranged that way, but it's not. I think they were just in the order they showed up on your album. But yeah, so our minimum looks like it's 5.28 minutes. And then the longest song was that 9.78 minute long song. And then go to the calculator to get our median, 5.78. And then we have what's called our quartiles, quartile 1 and quartile 3. Because quartile 2 is actually what?
The median.
So the quartiles are like medians of the halves.
Oh, yeah.
So, and I'll go ahead and show this all by hand as well. Moby, what the are you doing?
Well, while you guys are talking about math stuff that I don't understand, I was going to fold my laundry.
Oh my God, you're on the video still.
Yeah, I know.
Leave it.
Yeah, because I love having these calls with you guys, but at some point you go into the minutia of math and it kind of loses me. So I figured I would listen to your beautiful voices and fold laundry at the same time.
Okay, thank you. The first quartile.
You like how I threw in the compliments so you wouldn't be mad at me for folding laundry while you talk? Oh, here's a t-shirt. Here's a t-shirt, Lindsay, you might like. Can you see it?
Yeah, I can't tell what it is though.
It's a picture of Ronald McDonald's his corporate death burger.
That's great.
Okay, that's pretty good. I was hoping you were going to hold up like a tie-dye.
No, I don't like tie-dyes.
Oh, I'll make you one.
Thanks.
What I heard was, I don't have a tie-dye, please make me one.
Yeah.
Okay.
Tie-dyes I was raised by hippies, and tie-dyes remind me of childhood, so I don't like tie-dyes.
Okay. Okay, so back
childhood was terrible, not that anyone's asking.
Oh my God.
No, go on.
So, Natalie, when we do a box plot, the first thing we do is we graph the median. So a lot of people, it's counterintuitive because they want to start with like the minimum or the maximum, but you want to start from the middle and work your way out when you graph these, because you don't really know where the little whiskers of your plot are going to go up to, like down to the lowest value that's not an outlier and up to the highest value that's not an outlier. You actually need your quartiles and your median in place so that you can figure out if you have outliers.
Right.
So the median is 5.78. So just kind of like roughly, I'll say the median is hanging out right in here at 5.78. And then after you've got your median graph, you draw that little vertical line segment. And how high or low you put it or how long or short it is not mean anything numerically. It's just aesthetics. And then we're going to put our quartiles in. So put in your first quartile. Q1 is 5.57. I should have probably shown this a little bit, like a more detail on my scale, but that's fine. So quartile 1 is 5.57. And then
Quartile 3 is 7.55.
so we'll go ahead and note that is quartile 3. Okay, so once you get all of your quartiles and your median graphed, you want to connect them with this little horizontal line segment, and that's the box of your box plot. And the next thing of interest is we want to know how long that box is. And so we want to know what's the length of this. And the length of that is called the what?
The interquartile range.
Yeah, so for short, the IQR. And how do we find that?
You're just going to take that Q3 and subtract Q1, right?
We are, yeah, because you're going to take the bigger number minus the smaller number. That gives you the length of the box. So Q3 minus Q1. So what would 7.55 minus 5.57 be?
1.98.
Yeah, 1.98 is the length of our IQR. Now we use the IQR to help us find what next.
The fences?
Yeah, I call them fences. A lot of times the text call them upper and lower outlier boundaries. The fence lower and the fence upper. And I like that because then I can write FU on my paper. Okay, so then the lower fence, we're going to take that first quartile and say we can go a little below that. Did you say something, Moby?
Oh, I'm putting away socks.
Okay. That part.
Yeah, they're so neat. They're so neat in there.
Show us again. Show us your socks.
Well, so I buy like these bulk socks, and so they're all the exact same except for then like warm, like fuzzy socks.
Okay.
I do that too, only one sock.
Your maid does that, Natalie.
Yeah, I know, because I'm more of a celeb than Moby.
I like cleaning. I like doing laundry.
I do all my own shit.
I hate it more than anything.
In a way, I would just like to point out that we are sort of involved in some very modern gender role reversal in that, like, you guys are doing math and I'm cleaning the house.
That is amazing.
Good. Yeah, this is good stuff.
Do you want to see my sweatpants drawer?
Yeah, we do.
Hell yeah.
You've got like the sweatpants, but you also have yoga pants, which aren't quite as thick as sweatpants. Sorry, back to math.
So after you get your box drawn, we want to say, okay, outliers, like this is the middle 50% of our data. So not all your data is going to hang out in there, obviously only the middle 50%. The rest of the data should hang pretty close to that box. How far is too far away to be considered like consistent with the data sets?
Right, so this is why we have to find the fences.
Yeah, the fences serve as our boundaries. So what we do is we say, let's let the lower boundary, the lower fence, take the first quartile, and let's go a little lower than that.
Yeah, so minus 1.5 times that interquartile range.
Yeah, we're going to take that IQR and say, let's go 1.5 times that below. So we can kind of say, oh, we're going to take 1.98 and then half of 1.98, and we'll call that the cutoff.
Yes.
So we'll go ahead, and that's a formula that we can always refer to. And so we can sub in our pieces. So Q1 is 5.57 minus the 1.5 is a constant in this formula. So that's there regardless of your data set. We always go time and a half below the below the quartile.
Right.
And then we found our IQR earlier. What does that equal?
1.98.
Right. So then we sub in the IQR of 1.98. And then what do we get out for this?
That comes out to 2.6.
2.6. Okay. So then I like to go ahead and draw these kind of in red in my picture. Now, when you graph a box plot on your calculator, it doesn't show the boundaries, the fences. It doesn't show them. So this is something you have to be able to do. So I like to draw them as a little bracket facing inward, saying you got to be in here. If you're outside, you're an outlier. So 2.6 would be here's 2.5. So 2.6 would be here-ish, our lower boundary. So do we have any songs that are below 2.6 minutes long?
We don't.
What was
Right?
our minimum song length?
It's 5.28. So no, we definitely don't.
Yeah, so that means now we can do the next part of our graph on this lower end, and that's draw the whisker. So the whiskers the lower whisker goes down to the lowest data value, so 5.28. That is not, I don't love that. The lowest data value that is not an outlier. Now on this side, it happens to be the minimum because we don't have any outliers.
Right.
Okay, now we gotta check the upper side. Can we just draw that whisker all the way to the maximum, or do we have an outlier we have to consider? So the upper fence, FU, is quartile 3 plus time and a half the IQR. Help me out.
Okay, so Q3 was 7.55 and then plus 1.5 times 1.98.
Nice. And did you do that beautiful mental math in your head?
I did, and that came out to 10.52.
Okay, so 10.52. So then our upper fence is, here's like 10.5-ish. So here-ish. And then you have to look at your data and say, do we have anything outside of that boundary? So do we have any songs that are longer than 10.52 minutes long?
We don't, right? Because the max is right there, which is 9.78.
Yeah, our maximum is 9.78, which is within bounds. So 9.78 is about right here. And so we can actually extend our whisker all the way over to the right. We don't have any outliers on the lower end or the upper end, even though this one we thought maybe the 9.78 might be because it's longer than the rest. But it's longer, but it's not an outlier. It's getting close.
Right.
It's not there. Now, can you tell from this box plot the shape of the distribution?
Yeah, it becomes really nice and clear that it's skewed right.
Yeah, we've got that long right whisker.
Yeah.
And then, okay, let's suppose just for a minute, skewed right, that our maximum song wasn't 9.78. Just for a moment, let's pretend that Moby was really into this song and it was actually 10.78 minutes long. Just fantasy. Obviously, that would change the mean.
Yeah.
But the nice thing is, looking down here, it wouldn't change any of these other values. It wouldn't change what the minimum is, wouldn't change the quartiles, because they're all measures of position.
Yeah.
So whether this is whether this is 9.78 or 100.78, those positions don't change. The other ones, are you with me?
Yes.
That's kind of cool. Okay, so let's just say it was 10.78 for a second. If it were 10.78 and we knew we had our upper fence at 10.52, remember this is at 10.52, then would we have an outlier?
Yes, because it's greater.
Okay, so then we would have to change our whole whisker drawing. We'd have to say, okay, actually we have an outlier at 10.78 and things are a little harder. Now we say, okay, if I have an outlier, I can't draw my whisker all the way out to it. That's the tempting thing. Your whisker cannot cross that boundary though. So your whisker actually goes up to the highest data value that's not an outlier. So then you have to look at your data and say, oh, well, this one's an outlier, so I can't let my whisker go out to it. So what's the next highest data value?
The 9.28.
Right, and is 9.28 inside 10.52?
Yes.
So that one's safe. So
Yes.
then you go to your picture and you say, here's 9.52-ish, and your whisker will go there. It would have been nice if the data set just had an outlier to begin with, because I want to show what you do when you have an outlier. Let me do it on the calculator. Let's look at a box plot via our calculator. Because if you're doing this at home, why not just do it on the calculator?
Right.
It's there. All right. So always pick the box plot that will show outliers if they are present. And it's that first selection. It looks like there's two box plot options. The second one throws out outliers if they exist, and you don't want the calculator to make that decision for you. You want to be mindful of if you have them or not. So always select that one that shows the little points. Those are, if they exist, the outliers will show. Then hit zoom 9.
Ooh.
Zoom 9 is your fast, yeah. And then you can trade. And see, this looks like the one we drew by hand. We've got our minimum, our first quartile. I just hit trace and the right arrow, and that takes me to all of this. Great. Now, this one doesn't have any outliers.
Yes.
But the technology is a great way to show that if we go stat edit, actually, I kind of like the idea of sorting the list. I just find that to come in handy a lot of the time in ascending order. But what I want to do is go to the highest data value we have, which was 9.78. And I just want to change that to 10.78, just for funsies. See what that does.
Okay.
Okay, would that change our quartiles or our median?
No, that's actually not going to change it. If you think about how you find the median, that's definitely not going to change it.
Right, those are measures of position. So they don't care what the highest value, that highest value, I could change this. Watch, this is kind of fun. Let me just clear this. I could change this to 100. That's dramatic. And obviously that would very much change our mean.
Yeah.
Like our mean's way bigger, but our 5-number summary, except for the max, of course, but I just changed it, they're all the same because they don't care about what the value of that highest position is. They just care about the positioning.
Right.
Okay, but the point I want to make, actually, before I get excited about all the number theory stuff, is if we change that to, like, reasonably, he could have made a song that was 10.78 minutes long. How would that change our graph? So we've already got the box plot set up. If I hit to zoom 9, do you notice how now this time we have an outlier?
Yep. You see it over there on the right.
Yeah, and you can trace, and you still got your min at 5.28, Q1, median, Q3, but now notice the whisker only goes up to 9.28. It goes up to the highest data value that is not an outlier.
Right.
Notice the fence, the boundary is not showing on this graph. Your calculator doesn't show that or how it got it. Like, that's all just behind the scenes secret work that your calculator doesn't like let you be on the inside of.
Yes.
So if you need to know those boundaries, you have to find them by hand.
Right.
But realistically on your homework, when you're graphing a box plot, zoom 9, trace, and your whisker goes up to whatever this value is. You can find that by just hitting the trace. And then your outliers, and you might have more than one. You just keep hitting trace to see what they all are. And it becomes a very quick problem.
Yep.
Nice. Okay, thanks, Moby, for doing your laundry and math with us.
Thank
Well,
you.
technically, I wasn't really doing my laundry. I was folding and sorting my laundry.
That's part of the process of doing laundry.
I thought doing laundry was just like putting it in the washing machine and then dry. Like to me, like that's the doing of the laundry. This was the post doing.
No, doing laundry is sorting, putting in the machine, transferring to the dryer, folding, putting away. It's a whole process. So every part of that is part of the set of doing laundry.
Yeah,
Yes.
perhaps we just have a different understanding of things.
Okay. More later. I'll talk to you tomorrow.
Okay. Bye.
Bye.
Oh.